All right, let's dive right into this explainer. We're looking at how medieval scholars in the Middle East basically built the absolute foundations of our modern scientific world. We often think of science as a strictly modern invention, a product of recent laboratories and supercomputers. But today we're exploring a period in history that completely changed the trajectory of human knowledge. So think about this for a second. Where did the everyday systems we rely on, stuff like modern medicine, algebra, and optics, where did they actually begin? You might be surprised to learn that the answers are sitting over 1,000 years in the past, cultivated by some truly brilliant minds in the Islamic world. Today we're going to walk through 5 main areas. 1. The Islamic Golden Age. 2. Miracles of medicine. 3. The birth of chemistry. 4. Seeing the light. And 5. Mathematics and the stars. Let's jump straight into Section 1. The Islamic Golden Age, translating the ancient world. This was a time in Baghdad when pursuing knowledge was just a massive, organized, and celebrated effort. We're talking about a continuous chain of absolute genius unfolding over hundreds of years. It kicked off in the 8th century, with scholars at the House of Wisdom in Baghdad translating these vital ancient Greek texts into Arabic. But here's the thing, they didn't just copy them, they pushed the boundaries way forward. You've got Rhazes pioneering medical observation in the 9th and 10th centuries, Ibn al-Haytham unlocking the secrets of optics in the 11th, all the way to the 13th century when the massive Mansouri Hospital opened in Cairo. It is just an unbroken lineage of innovation. Moving right along to Section 2, Miracles of Medicine from textbooks to mega hospitals. The crucial thing to understand here is that these thinkers didn't just study medicine in an abstract way. They totally revolutionized actual patient care. Take the brilliant Dr. Rhazes, for example. When he was asked to find the most sterile location for a new hospital in Baghdad, he didn't just guess, he acted like a true scientist. He ran this incredibly clever, practical experiment where he hung small pieces of meat in different neighborhoods and, well, just waited. He observed the decay rates and then ordered the hospital to be built right at the site where the meat rotted the slowest. He correctly figured out that that would be the healthiest, cleanest environment. How smart is that? What you really should take away from this is that they practically invented the modern hospital system. We're talking astonishingly modern setups. They had up to 24 doctors on staff, including dedicated specialists like eye doctors and surgeons. They even built outpatient clinics and medical colleges right inside the hospitals so students could learn hands-on. And, crucially, they created separate wards to isolate infectious disease patients and mentally ill patients from everyone else, which is exactly what we do today. And check out this rule from the Mansouri Hospital. It highlights a breathtakingly advanced humanitarian ethic. They provided free care for absolutely everyone. Honestly, they didn't care if you were a resident or a foreigner, rich or poor, employed, blind, sighted, learned, or illiterate. It just didn't matter. The mandate was simply to heal. Patients were kept until they were completely recovered, and the hospital footed the entire bill. To put that operation into perspective, 8,000. That is the staggering number of patients the Mansouri Hospital in Cairo could treat at a single time back in the 13th century. Actually, a visitor to a similar hospital in Baghdad in 1184 described it as looking like a great castle, complete with its own river water supply, saying it was as well equipped as a royal palace. We also absolutely have to talk about the polymath Ibn Sina. His encyclopedic medical textbook, The Canon of Medicine, was essentially the gold standard in Europe for, 500 years. It gathered and organized pretty much all the medical knowledge available at the time. Its influence was so profound that European doctors were still relying on it as a primary reference well into the 1500s. I really love this next detail because it perfectly connects their ancient pharmaceutical practices to the words we literally speak today. So they use things like cannabis as anesthetics, right? But to make harsh medicines easier to swallow, Muslim scientists would expertly dissolve plant and animal extracts into liquids like rosewater or orange water. The Arabic words for these mixtures, kuhul and shurub, are exactly where we get the modern English words alcohol and syrup. Okay, on to Section 3, the birth of chemistry, turning magic into method. Let's look at how this sort of secretive, mystical search for gold transformed into a legitimate science. While a lot of alchemists were running around arguing over how to turn lead into gold, scientists like Jabir ibn Hayyan and Rhazes were actually doing the heavy lifting, laying the foundations of modern chemistry with tangible, real-world experiments. Over in the 8th century, Jabir ibn Hayyan formalized essential processes. Think distillation, crystallization, and sublimation. And he used this practically to waterproof cloth and invent rust prevention varnishes for iron. Then, in the 9th and 10th centuries, Rhazes took it a step further. He classified chemical substances, mapped out reactions, and literally designed the lab equipment needed to pull these experiments off. They were discovering mineral acids and ammonia, effectively turning magic into strict scientific methodology.
That brings us to Section 4, Seeing the Light, the Physics of Vision.
Here we meet Ibn al-Haytham, a guy who literally changed how we see the world. I mean that. He overturned centuries of incorrect Greek beliefs, kicking off a massive paradigm shift. Up until then, the prevailing thought from ancient Greece was that human eyes worked kind of like little flashlights, emitting rays of light out into the world to illuminate things. Well, al-Haytham proved the exact opposite. Through really rigorous physical experiments detailed in his book on optics, he showed that light actually reflects from an object and then enters the eye. He basically gave humanity its very first correct explanation of vision. And it is truly mind-blowing what he did next. Based entirely on his groundbreaking studies of light reflection, he didn't just solve human vision, he managed to measure the sky itself. By understanding how light bent and reflected, he expanded his focus to the atmosphere, calculating its depth to be about 15 kilometers, with incredible ingenuity. His work became the absolute bedrock for the science of optics that European scholars would pick up centuries later.
All right, our final section, number 5, Mathematics and the Stars, Mapping the Universe.
So, looking upwards and outwards, let's explore how math and astronomy unlocked the cosmos. First off, think about Roman numerals. They were clunky, hard to write, and incredibly difficult for complex calculations. Try doing long division with Roman numerals. Actually, don't. It's an absolute nightmare. But by borrowing the Hindu concept of zero from India and developing Arabic numerals, mathematicians allowed digits to be arranged in columns of tens and hundreds. This simple change completely revolutionized European trade and math by the 10th century, making complex calculations vastly easier and significantly faster. And hey, if you've ever struggled with algebra in school, you basically have Al-Khwarizmi to thank for it. He developed this incredibly clever system of letters and symbols to solve equations. In fact, the very word algebra is directly derived from the Arabic term al-Jabr, which beautifully translates to the reunion of broken parts. But remember, mathematics wasn't just abstract theory for these scholars. It solved highly practical, everyday problems. Merchants, sailors, architects, they all used these new tools. They could accurately measure large agricultural fields, figure out exactly how much cargo a merchant ship could hold, and vastly improve the speed and accuracy of global trade. Even those breathtaking, intricate geometric patterns you see decorating historical Islamic buildings, that's the direct result of their mastery of advanced geometry. And of course, they applied this math to the sky. Even though they operated under the belief that the Earth was the center of everything, these brilliant astronomers mapped out celestial movements with astonishing precision. Using advanced math, scholars translated ancient works and just made them better. Al-Battani in Syria actually corrected the mathematical errors of the ancient astronomer Ptolemy while observing eclipses. Over in Persia, you had the incredibly clever al-Biruni using eclipses to calculate global longitude. And in Egypt, Ibn Yunus dedicated himself to the stars, writing a comprehensive astronomical guide for prayer times. Speaking of Ibn Yunus, let's talk about the number 10,000. That is the number of complex mathematical calculations he made regarding the sun's position. 10,000. He created tables so incredibly accurate that they were actively used in Cairo all the way until the 19th century. Just imagine calculating the sun's position 10,000 times by hand without a computer and getting it so perfectly right that your work remains a standard for nearly 1,000 years. So I'm going to leave you with this thought to ponder. The scholars of the Islamic Golden Age didn't just preserve the past. They enthusiastically built the future. They gave us the algebra we learn in school, the blueprint for the hospitals that heal us, and even the very words we speak. If their dedication to structured learning and practical experimentation echoes so loudly today, what discoveries are we setting in motion right now? What seeds of knowledge are we planting today that will be celebrated 1,000 years in the future? Thanks for joining me on this explainer. It's definitely something fascinating to think about.